Oh, I'm hearing all different answers, and that is not good. Odd means we have symmetry about the origin. Oh, odd. Oh, odd. Symmetry about the origin. Now, your choices are, you can try to graph this thing, which is not going to be easy. It's definitely doable, but it's not going to be easy. Or you can use the test of symmetry for the origin. Now, if you're looking at me and saying, test of symmetry for the origin, what's she talking about? It means you haven't watched the 1.2 video, your e-learning assignment. Remember, the 1.2, or the test of symmetry, there's 4 tests of symmetry. Does anybody remember what the one for the origin is? How we do it algebraically? Emily, what? Well, what is the algebraic test we do? What do we do to the equation to test for symmetry? Oh boy. Nobody took notes over that video? Oh, what now? You put in if you're doing the origin, you not only put in negative x, but you also put in negative y. The test for the origin is we change the signs on both. Was that a cube or a square? Oh, that was a square. You guys have one more night to watch that video. I would strongly suggest it if you haven't. Take notes and follow what's going on here. All right, so the test of symmetry says we're going to change the signs on the x's and the y's. So if I do that and then simplify, look what, I might have to keep doing that. What happens when I square my negative and I square that negative? What do I end up with? The original problem. And when you end up with the original problem after you've done the test, you end up with the original problem, it means you do have symmetry. So the answer to the question is, yes, it is odd. And why? Because it passes the test for symmetry about the origin. Number 2, identify with words or an equation. What is that thing? It's the logarithmic function. Yep, so you could either say it's the logarithmic function, or you could say y equals ln x. That would be your equation. Name a BFF with n behavior. The limit as we go to the right for the function is positive infinity, and the limit as we go to the left of the function is also positive infinity. Now, what does that mean? This is end behavior. What does that mean? At the ends of the picture, all the way to the right, all the way to the left, what is happening to the curve? Shooting up. On both sides, it's shooting up. So think of one of your BFFs that shoots up. The parabola, the quadratic function, the squaring function, the parabola, absolute value, shoots up on both sides. Those are 2 we can think of right away. All right, consider this function. Vertical asymptote, horizontal asymptote holes. You can cross off the intercepts. We have not been dealing with those just yet. This is an old quiz. Whatever year it was, I was focusing on that at this point. We are not. But we do have to know about our asymptotes and our holes. All right? So I have factored everything. I just did that as I wrote it down. Is that okay with everybody? Okay. So now what? What do you notice? We can cross out. And as soon as we cross out, that means we're going to have a hole. Now I'm going to take care of that right now before I forget. The hole is a point. where will the x-coordinate of the point be? -1. Why is the x-coordinate at -1? Because that's what I canceled out, right? X plus 1, so my whole is at -1. We're going over this sheet right now.
Okay.
Here. Also, we handed this out earlier. Now, the whole is a point. I have the x-coordinate figured out because that's what I canceled out. How am I going to get my y-coordinate? Plug in the -1 right here. So that would give me -6 over 2 times -2, which is -6 over -4, or 3/2. If I did my arithmetic right. So there's where my whole is. Now, what about vertical and horizontal asymptotes? Horizontal is y equals 1/2. And she's getting that absolutely correctly right here. X over 2x. Horizontal asymptote at y equals 1/2. What about a vertical asymptote? X equals 1, because if you put 1 into the problem, that's a minus. If we put 1 into the problem, what's going to happen to the denominator? It's going to be 0. And if the denominator is 0, bad news. Okay, everybody all right with that? All right, now, what is the domain? Okay, here we go. A, what's your domain? X is greater than or equal to 3. So you'll either write x is greater than or equal to 3, or you will write it in interval notation, whichever you prefer. Why is x greater than or equal to 3? Because whatever is under the radical must be greater than or equal to 0. Every time. All right, what about b? What's your domain for b? Oh, it's not all real numbers. X cannot equal 0. Because why? Denominator can never equal 0. If you have a denominator, it can't equal 0. All right, now we've got a couple quick sketches. This should not be a problem for you because you've memorized this. All this says quick sketch. Not doing anything to this first one, we're just sketching it. So you do need to be able to label your axes. So remember, the cosine and sine oscillate back and forth between 1 and -1. And our labels in radians, 1 time around the unit circle. None of that makes sense to you, but you're just memorizing it right now. And this would be your cosine curve. Everybody in agreement? You better be, because it's right. That's the cosine curve. That should not, you should not be struggling with that. That needs to be memorized. B is a little bit trickier because I stuck that negative in there. What does that negative do? Flips it upside down. So you're going to have your regular absolute value V, but it's going to be turned upside down. Right now we've got some random picture, and your job is to tell me the domain and range of that picture. The domain is all real numbers. Domain is X. Doesn't this picture go forever and ever in both directions? Left and right, I mean. What's my range? -2 to infinity. Either y is greater than or equal to -2 or -2 to infinity. That is your range. Now name the intervals on which the thing is increasing. Now, what does increasing mean? As I draw it, my pencil goes up. Okay, so start tracing over the curve. When does your pencil go up? From -3 to -1. Remember, we're moving left to right, so we're talking about x values. So from -3 to -1, my pencil's going up. Would you agree with that? Is there any other time my pencil is going up? I think there is another time my pencil's going up. From 3 to infinity. After 3, it just keeps going up, 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 up.
So would you not bracket those?
No. You do not bracket because at the point, like look at -3. On one side it's decreasing, on one side it's increasing. You can't call it one or the other. All right, sketch. All right, this is another absolute value. Stuck a couple of numbers in there. What do those numbers do? What does the 1 do? To the right 1, and the 2 goes up 2. So you're going to have your regular absolute value V, but instead of being at the origin, it's been moved over 1 and up 2. So it is being from the point 1, 2. Now we got another symmetry question. So again, the question is, what's the test of symmetry for the line y equals x? Anybody happen to remember that one? No, this is different. We're testing for symmetry about the identity line. So the test is different. If I were doing the origin, I would change the sign on x and y. But I'm doing this line, do you remember? Maria?
Did you switch x and y?
You do. Thank you, Maria. She took notes. Thank you. You switch x and y. So you write this equation. And then you simplify it and see if what happens. If it's the same as the original. It doesn't look like it's going to be, but let's do some rearranging. So I'm going to add the y over here and subtract the x over here. Oh my gosh, did it turn out to be the same equation? So the answer is yes, we have symmetry across the identity line. Because why? Because when I did my test of symmetry, I ended up with the same equation. Okay? I thought that had some good review on it. I want to look now at review sheet 2. Have we done that together yet? We did 1 together? All right, good. Let's look at review 2. We may not get it all done, but that's okay. It's all done on video, and you need something to do tonight anyway. I want to look at a couple problems in particular, because one of them's a little bit tricky. Number 1 is not tricky though, but it's the last thing we learned, so I want to make sure we review it a little bit. What do we mean by implicit functions? What are we looking for on review sheet 2, problem 1A? How do we find implicit functions? Solve for y. So y squared equals x over 4. So y equals plus or minus the square root of x over 2. So there are 2 implicit functions, this one and this one. Now, let's just talk about this for a brief moment. These implicit functions, this is like 1/2 root x, right? What does root x look like? That's right, Wyatt. It looks like this. Now, putting the 1/2 in it makes it half as tall, so it kind of shrinks it a little bit. What does negative root x look like? Negative root x. What would that do? That would take this and flip it over. So if I put the two together, if I put both of my implicit functions together, I would get that shape. Does that make sense to you? Look at the original equation. It was a squared, but it was y squared, which means it's a parabola opening left and right. So your implicit functions just allowed your calculator to graph that parabola. All right, what about the second one? What are the implicit functions for this? What would you do here? Same thing, we're going to solve for y. Yep, so 2y squared equals 8 minus 2x squared. Probably divide by 2. And take the square root. Now, are we going to simplify that? No, we are not going to. There is nothing you can do with that. That does not simplify. Don't you dare take the square root of each piece. It doesn't work. You can't do it. Illegal. Here are your implicit functions. Stop right there. That's pretty easy, isn't it? Solve for y. Get y by itself. Almost always, not always, but almost always involves taking the square root. Okay, now it's this next one that is the interesting one. Oh, this is the question. This is backwards of what we did when we practiced these together. This means composition. So how would we read this? G of f of x, and it equals that. Now, the question says, okay, let's go backwards. What were the two functions that when you plugged f into g, you got this? Now, it seems hard, but it really isn't. I want you to think about this for a second. If I picked a number like 5, and I put it in here, I said I'm going to let x be 5, what would be the first thing I'd need to do? Square it. Okay, so let's keep track of this. I'd have to square it. And then what would I have to do? Multiply it by 3, and then I would subtract 1. And then I would have to do it in that order, right? So I'd square, I'd multiply by 3, and I'd add 1. Those are the 3, whatever the number was that I started with, I'd square it, then I'd times it by 3, and then I'd add 1. Those are the 3 operations that have to happen. Now you only have 2 functions, so one of them is going to have to do 2 of these things, and the other one is only going to have to do 1.
Why would you add 1? Subtract.
Oh, subtract 1. Oh, sorry, you're right. You wouldn't add 1. You'd subtract.
Okay.
Yeah, I got to square times by 3 and subtract 1. That's what this function is doing. So I'm just going to throw out there, in the composition, g of f of x, you start with f, right? So I'm going to let f be the function that does both of these things. So f is going to be the function that squares a number and times it by 3. And then g only has to do one thing. The only thing left to do is subtract 1. So g is the function that subtracts 1. Now look, if you took these 2 functions into g of f of x, this means you take f of x and put it into g. Well, if you put f of x into g, do we get that? Do we get our answer? Mm-hmm. We do. So that would be one combination. There's another answer though. That's fine. That's perfect. But there's another one. Remember, there were 3 operations that needed to happen, and I let the first function do 2 of them. Well, what if I let the first function only do 1? What if I let the first function just square? Then what does the second one have to do? Times by 3 and subtract 1. So it's going to be 3x minus 1. It's going to multiply by 3 and subtract 1. And again, if you put f into g, which is what the problem says, put f into g, you get the same thing. Both of those are completely legitimate answers. Let's try another one. Some of you look like you get it, and some of you look like you're a little bit foggy on this Monday morning. So let's try another one. Let's say g of f of x is 4x plus 1 over 2.
So on the test, we only put one of those?
Oh yeah, you only put one.
Okay.
So this is kind of a grading nightmare because this answer would be okay and this answer would be okay, and you don't do both, you only do one. Okay? So now let's look at this one. Now, it's really important, kids, that you stay organized, because if it's g of f of x, f has to come first. Right? F does the first things. All right, so look at your problem. What needs to be done in this problem? You need to multiply by 4, add 1, and divide by 2. In that order, right? Multiply by 4, add 1, divide by 2. So then you say, okay, my first function maybe just multiplies by 4. That's fine. But then what does your second function have to do? Add 1 and divide by 2. Or, and again, we don't have to do both of these, but you may think about it as, all right, I want to get it over with. I'm going to let my first function do 2 things. So what would your first function do? Multiply by 4 and add 1, and then your second function just has to divide by 2. Either one of those is perfectly fine. Is that okay with everybody? Okay. All right, take a skim down through there, the rest of the problems. And what do we have limited time, so what would be the best thing for us to talk about? Yeah. 18. Well, I need to get my calculator out. Notice that 17 and 18 are the calculator problems. This test will be divided up very specifically into calculator, no calculator. And this will be a calculator problem. So what do? I don't stat plot. First I go into stat, edit, and I put in that set of numbers. So one list is 1, 2, 3, 4, 5, 1, 2, 3, 4, 6, and the other list is those numbers. And then once I get those into stat, edit, and I get those 2 sets of numbers in there, then I have to maybe draw a picture of it. And why would I do that? What is the purpose of plotting those points? What am I trying to decide when I plot those points? Is it a linear regression or is it a quadratic regression? And how the points end up plotting tells you that. So they're either going to pretty much lie in a straight line, or you're going to see some kind of curve. And you're not going to see the whole parabola, but you might see something that looks like this. Okay? I don't know. So once you've got them plotted, and how do we plot them? We have to use stat plot to get them plotted. And kids always say, especially with this kind of data, well, I don't see very many dots, because you didn't set your window big enough to handle from -1 to 54. Your y's have to go from -1 to 54 for like -5 to 60 or something like that. So then we stat plot the picture, then we decide, is it anybody got it? Is it a parabola or a line? It's a parabola. Okay, so the only reason I graphed it was to determine that I'm going to use quadratic regression. Because it's a parabola, that means quadratic. So then where do I go next on my calculator? Back to stat. And now I go to calc. In my stat menu, I go to calc. I click down till I get to quadratic regression. And it then is going to give me quadratic regression. The equation looks like this. And it's going to give me an A, B, and C value so that I can write my equation. So anybody have it? Y equals, anybody got it? What is it, 3x squared?
2x squared.
2x squared?
Negative 3x. Plus 0.
Plus 0. Okay. So it's just 2x squared minus 3x. That's your equation. Now, what often happens, didn't happen here, but what often happens is there's a secondary question that says, okay, you got all this data. What would be the y value that would correspond with an x value of, let's say, 7? Well, once you've written your equation, that's easy, right? If we know x is 7, we'll just plug it in, and that will give us a y value. Okay, Maura, if you got issues, we can, well, you'll have to come in outside of class time, okay? And we can go through that. All right, anybody else see anything? Since nobody's saying anything, I'm just going to throw out 11 because we're sometimes not careful enough with number 11. When we look at this and we have to talk about domain, what am I thinking about? I'm thinking I got a radical and I have a fraction. So I have double trouble here. Since I have a fraction, my denominator cannot be 0, so x cannot be 2. Since I have a radical, everything under the radical must be greater than or equal to 0. Which means, now watch it, this problem was turned around, so x is less than or equal to 4. So my domain is everything less than or equal to 4 except 2.
So can we just put like x is also equal to 4, x is not
Yep.
equal to 2?
Yep, you can list both of those, that's fine, or you can do it in an interval. If you do it in an interval, be careful, it's going to take 2, because it's negative infinity to 2 and then 2 to 4. How about the piecewise function? Can we sketch that?
What number is that?
15. Okay, this is the last one, and I'm going to hand back your last test. I don't think I've done that yet, have I? Oh, I did? Okay, good. Well, then I don't have to do that. All right, so I'm going to sketch this thing. Here we go. Okay, so remember how we do this? What's that? The line. That is the identity, right? Adding 1 to it does what? Moves it up 1. So we're going to have this line right here. Picked up 1 unit. I don't want the whole thing though, do I? Never do in piecewise functions. We always just want pieces of stuff. So what's the piece of this line I want?
Greater than negative 2.
The piece that starts at -2, I'll put an open dot there. What will be that coordinate? -2 comma what?
-1.
-1, very good. We get our y coordinate by plugging in our x coordinate. So -2 gives us -1. What piece of that line do I want? The left piece or the right piece?
The left.
I want the left piece. Why do I want the left piece? Because it's less than. Alright. What's that second equation look like? The middle line there. What does that look like? Y equals 5. That's a horizontal line. There it is. There's the whole line. But I don't want the whole line. What piece do I want? The piece that starts at -2. So this would be the point, -2, 5. Do I want the right side or the left side of that? I don't want any of it except that point. That's the only thing I want, is that one little point. What's that bottom equation? It's your x squared parabola. There it is. Do I want the whole thing? No, I want a piece of it. And what piece do I want? The piece that starts at -2. So -2 will come up at, oh, well, my picture's not very good because it's supposed to come up at 4, isn't it? So it comes right here. There's -2 comma 4. Open dot. I got 4 by plugging -2 in here. So -2 comma 4. And which side do I want? Do I want the left side or do I want all this over here on the right side? Everything on the right side, so I'm going to erase this. And there is my picture. The range is everything greater than or equal to 0, everything less than -1. Got a hole in the middle of it here, so it's greater than or equal to 0, less than -1. Number 7, what's the domain? Y equals 3 minus x squared. What does 3 minus x squared look like? This is a no calculator problem, so you're not just going to type it in. You got to know. Yep. What does that look like? Upside down parabola. Basically, we've added 3 to it. This is the same as -x squared plus 3, if you like it better that way. So you've taken your upside down parabola and moved it up 3. What's its domain? All real numbers. Would you say, this had another question, would you say it's bounded?
Yes.
Well, it's not bounded, it's bounded above, right? It's bounded above at y equals 3. Technically, remember, you have to indicate, if you say bounded, that means it's bounded above and below, right? This is not, so you want to say bounded above at y equals 3. Do we have any BFFs that are bounded? Cosine and sine are both bounded between -1 and 1. I can think of one more. Logistic is bounded between 0 and 1. Right? Asymptotes at 0 and 1. Okay. What else have we got
So,
here?
say for number 10, would that be bounded?
Number 10. Well, I don't know. Bounded means it has a ceiling or a floor or both. I mean, bounds are ceilings and floors. Does that thing have a ceiling? Does it have a ceiling? No. Does it have a floor? No. Now, if you looked at individual pieces of it, you would have a different conversation, but we're not. We're looking at the whole function. It is not bounded. Not bounded.
You want to use the graph portion of the test, it's not, you can't use a calculator, like what type of stuff would that be?
You're not using the calculator for anything except like these last two on here. That's it. That's all you're going to have a calculator for.
Alright. Can we do 17?
17. To find the relative maximum and minimum, well, you're going to type this equation into your calculator, and you're going to hit graph. And chances are it's going to be some kind of a regular, normal cubic curve. It's going to have some kind of shape like that. It's going to have a hill and a valley. And your job is to find the relative maximum, which would be that point right there. Now, I don't know what it looks like. I just randomly sketched that. But you should see a hill when you graph it. So we're looking for the point, since it says maximum, we're looking for the point that's the top of the hill. Now notice it didn't say find the absolute maximum. Why didn't it say find the absolute maximum? Because we don't have one, right? So if we want to find that point right there, to find that point right there, we do it exactly the same way we do zeros. So if I told you to find this point right here, what would you do? Second calc, and you pick 0. Well, this time you're going to do second calc and pick max. And then you're going to set a left bound, a right bound, and take a guess. That too is in the 1.2 video, that discussion. But you're lucky because it's exactly the same as finding the zeros, except when you second calc, you pick maximum or minimum, whichever one you're looking for. Obviously, if when you hit graph, you didn't see the top of the hill, you have to make your window bigger because you've got to see the top of the hill in order to find it. All right. Okay, tomorrow's test day. Come with both reviews ready, and we'll be ready to talk to it. Have a great day.
That's not good.